you ready? Ladies and gentlemen.
Welcome to the alpha particle scattering experiment. Let's delve into the experimental setup. The experiment used alpha particles, which are positively charged particles emitted from a radioactive source, typically radium or polonium. A very thin sheet of gold foil was used as the target for the alpha particles. Additionally, a circular fluorescent screen coated with zinc sulfide was placed around the gold foil to detect the alpha particles after they passed through or were deflected by the foil. Now let's discuss the procedure. First, alpha particles were directed at the thin gold foil. Then, the detection process took place. The detector screen detected the position and angle of deflected alpha particles, with flashes of light appearing where the particles struck the screen. Observations from the experiment revealed some intriguing behaviors of alpha particles. Firstly, the majority of alpha particles passed through the gold foil without any deflection, indicating minimal interaction with the foil's material. Secondly, a notable number of alpha particles were deflected by small angles as they passed through the foil, suggesting some interaction with the material. Lastly, a very small fraction of alpha particles were deflected at large angles, and some even rebounded almost directly back towards the source, hinting at a significant barrier or interaction within the foil. The interpretations and conclusions drawn from these observations were quite profound. The fact that most alpha particles passed through the foil with little or no deflection indicated that atoms are mostly empty space. The significant deflections and rare backward deflections suggested that the positive charge and most of the atom's mass were concentrated in a small, dense region at the center of the atom. This central region, later termed the nucleus, had to be positively charged to cause the repulsion and deflection of the positively charged alpha particles. You might wonder, why discuss the experiment first? Well, the alpha particle scattering experiment provided critical empirical evidence that necessitated a change from existing atomic models. Without discussing this experiment, the reasons for moving away from the Thomson's plum pudding model and towards a new model would not be clear. The plum pudding model posited a uniform distribution of positive charge with embedded electrons, which could not account for the large-angle deflections observed in the experiment, highlighting its inadequacies. Discussing the experiment emphasizes the scientific process of hypothesis testing, observation, and model revision. It shows how empirical evidence leads to the refinement or rejection of theoretical models. Understanding the experiment encourages critical thinking about how scientific theories are validated and the importance of experimental evidence in shaping scientific understanding. Explaining the experiment first provides the necessary context to appreciate the transition to the new atomic model. It sets the stage for understanding why a new model was proposed and how it better explains the observed phenomena. The alpha particle scattering experiment was a pivotal scientific experiment that challenged the existing plum pudding model and laid the groundwork for the development of a new atomic model. Discussing the experiment before introducing the new model is essential because it underscores the role of experimental evidence in driving scientific progress and theory evolution. The experiment's findings, primarily that atoms are mostly empty space with a dense, positively charged center, provided the critical insights needed to move beyond the plum pudding model and explore new conceptions of atomic structure.
Furious coders, breaking the code, innovations algorithm, watch the story unfold, Gravity and Cardi, a duo supreme in the tech world's kingdom, living the dream.